There you go. All right, we got the mic on. So let me repeat what I was saying. We have a few topics that might be interesting. One is backups versus snapshots. What's the difference? Is there a difference? The other one is application versus storage. So we're all storage folks. We think a lot about storage backups, but how is the user in Kubernetes going to consume backups? What's the unit they want to deal with? This other comment I heard was migration might fit into this. So we could just segue into migration also. Some of the discussions we were having yesterday when Jing and Jing were talking about restore volumes, I think that also has some relevance here. So first topic, backup versus snapshots. I can give you my take on this and maybe folks can jump in. When we think about snapshots, it's really that instantaneous copy of what the data is. And not necessarily, and that's really just the sole purpose of a snapshot, right? Creating a copy, most of the time is read-only, that you can hydrate later and get the data back. Backups actually have a lot more. There are connotations around policy, how often you take them, retirement, how long should they stay around, what are my compliance policies, can I actually restore this, have I moved it into a different tenant than where the source volume exists. So a lot of those are requirements that people think of when they're thinking about backups, which are not necessarily requirements for snapshots. Shows up a lot more with on-prem storage systems, I think, because snapshots tend to live on the same appliance. In cloud, this is less of a concern. Steve, anything to add here?
Yeah, I would say, in my experience, snapshots are they're potentially useful even if you don't intend to do a backup. So they are two different things, but I think in general, you don't see a backup process that doesn't require snapshots to be accomplished first. And the reason you need that snapshot, among other things, is that you're doing this usually to, well, assuming in Kubernetes, it's to back up an application or a service. In a legacy pattern with whole hardware servers or VMs, you might have had multiple things inside that VM. But in a Kubernetes world, we'll assume that this is a snapshot of one or more volumes in a pod associated with a service or application. And the snapshot is going to freeze it. And the reason that is important is that many applications will have state floating up in memory for performance, and they'll have an API call that tells them to quiesce. Generally, it would cause them to suspend service while this is going on, but this is a very quick operation, so they flush any in-memory state down to a file system. Sometimes an fsync on the file system is involved too. And at that point, it's stable so that you don't have things. I mean, certain file systems potentially have indexes to blocks, and unless you go through this whole quiesce and snapshot process, if you were trying to bring that back, it could be flagged as a dirty file system or even an invalid one. So the snapshot process isn't normally just storage alone, but often will involve an application being told to quiesce itself and then trigger the actual snapshot. It's kind of something that I'm not sure what kind of detail we've gone into, but the snapshot as we've defined it going through CSI is just recording that image. But I think in the real world, if this is associated with a backup, the application itself might be the one triggering the call to that API to create the snapshot. So as part of that workflow, it isn't necessarily an external admin so much as an app that you might want to see trigger that snapshot process. Then once you get the snapshot, it becomes a backup, by my definition, when you copy the snapshot to external storage. And most backup products would keep more than one along, and that requires a catalog. And part of the reason for the external storage is that many hardware implementations keep snapshots as a copy on write scenario with the storage volume itself, so that if the volume is deleted, all your snapshots are gone with it. And it becomes a backup copy to other storage, has a life independent of the volume itself, so that if the volume gets deleted or the physical device gets destroyed, the backups are still around. Because they can outlast the volume, they need this catalog, because you can get to snapshots generally if you know the volume, because they have a close association where you could look that up. But once this thing goes to external storage, that bond is broken, and in fact, the original volume could be completely gone. The catalogs, I think this is beyond the scope of what the storage SIG should try to declare as is within its domain, because to me, backup is an application itself, and there's a lot of opportunity for backup implementations to differentiate themselves with features involving the catalog.
It's a value add for vendors, right?
Yeah, if it's a commercial product, and I think there are some open source backup solutions out there as well. I've worked in the field, and it gets really complex just because you can have issues like, once you start doing a production-worthy backup service or product, the catalog itself is a big part of your development, because you can find things like in Kubernetes where the original volume is mapped to a pod which has applications, and they might have both GUIDs and somewhat meaningful names. But the trouble is, if you're trying to support a scenario where the original is deleted, somebody could create an application with the name Alpha 5 deleted, and then 6 months later, another independent person creates one with exactly that same name. If you lump them together, that's potentially really undesirable and invalid. Yet if you give them GUIDs, a user wanting to restore this isn't likely to be in a position to ever find it. So these catalogs actually become pretty big undertakings, but that need indexes on many terms, like the individuals who created it, when was it last used, when was it created, and there's a lot of metadata that typically gets associated with that. This thing, I think, what I'm suggesting to you is this is a complex application, and it's not really storage itself. It would be a user of these APIs, but I don't think you could conceivably create a backup working world, but there'd be no end to that. That could end up being, hours and hours of discussion trying to architect that, and you'll have completely valid differences of opinion. So the amounts of that you could standardize would be pretty limited. So I kind of declare backup to be an application and to be out of scope for the storage thing.
Bankrupt, it's done.
Yeah, but other people may have alternate opinions. A Kubernetes user might love to have a backup service commonly associated with their consumption of Kubernetes, just like they'd like a logging service or something else. But I think backup potentially in the long run, if there's an open source solution, then becomes a CNCF sponsored product of its own.
It's like database, it's like sponsored database, a relational database or something.
Exactly.
A whole different feature set for everyone.
Right. So I think what we should be discussing here is the snapshot and a standardized API for that would enable multiple people to build backup services. And they might have demands through this process of putting user-specified labels on the snapshot that could be used for this catalog. I think that's reasonably in scope. It's something that ought to be anticipated, that when you call the API the storage SIG defines, you should have the option of giving some labels that just get associated with it, because they'll be useful if these snapshots turn into backups. So that's my 2 cents worth there.
Do we even need that, though?
I think as long as we have the ability to take a snapshot and a volume to be created from that snapshot, we need to do more than that. Or is that the rest up to the backup application that they create the volume from the snapshot and do whatever they need?
Then as long as they have some event that knows that they should try to persist their own labeling. The thing is that the instant the snapshot is taken, you would like this metadata to be captured at the same point in time. If the backup runs nightly, which is common, things may have changed by the time the backup, between when the snapshot was made and when the backup occurs, which is potentially a window for ugly things to happen.
I would see it driven by the backup application, because I don't think in every snapshot we want to run backup.
Right.
I would think a backup would want to use a snapshot to create.
I can add something. So, some color on this that at Kasten, we are looking at building a backup solution, and it is open source, so it is Canister. And that's why we've been working with folks who are doing the snapshot API, and it's exactly what you said. It's that you need the ability to create a snapshot and rehydrate a snapshot into a volume. That's the primitive on which we can build. And attaching labels.
Can we back up and make it very clear what the difference between a backup and a snapshot is? So to me, in my head, a snapshot is something where it's locked into the storage system, whereas a backup, you get a artifact that can be moved around from that storage system.
So when you said backup and talk about this, pun intended, right? Okay, so that's the second part. I think the way to look at least the way I look at it is, what's the use case? Okay, so snapshot, you can think of snapshots at different levels, but snapshots make sense at the storage level. You're capturing a point in time of the storage. But backup of the storage or of a volume in the environment we are in doesn't make sense, because there's no use case that falls out of that. As in, if I want to back up a volume and restore a volume, what am I going to get from it? I'm not going to get my application back, because my application is actually not just that one volume. It works very well for when my VM is my application, this whole monolithic world where everything is one. So that's where I think here, someone also talked about consistency groups earlier. That's where things start to change, because everything is so distributed that backup is really that collection of everything that I can restore and get back the thing that I care about, which is really not the volume, it's the application. Might actually not be the application, might be the cluster. So I think that's the difference.
Yeah, it's something that's being consistent with so taking snapshots is easy. We can make an entire application scale. In this case, we like to save for customers in the that is what a lot of customers are trying to solve by having the entire tool state and being able to restore it.
But I think that goes back to what Steve was making. What do you define for the domain of backup? Like backup is just a backup of a storage entity, or backup is something where you can restore your volume state, including the meta and the data volume. Or you're talking about the backup of a pod, which basically defines the application state. So if you really talk about backup, I completely agree with Steve's points. Like there are multiple levels where people see the backup from. Like, of course, I work for a storage company, and we see backup as a problem for storage. But at the same time, we also see storage is nothing except an application is preserving some data on it. So it means a backup sitting in a remote place and you want to restore data from a remote place doesn't mean anything if application cannot really consume it in its normal point. Like backup generally people will associate it as a DR strategy, right? Like I have my original data lost, my source cluster went down, so all the snapshots that were hosting on the source cluster, they are out. Now I need to kind of surrender myself to an external point where I might have got a copy and I want to pull the data from there. So pulling the data from there always comes with different flavors, like you want to build your own application or you want to restart your application, presuming the application can somehow read the state from the data that you've stored earlier. So I think it opens up a lot other day when we were talking about consistency groups and all those things. I think that brings in a more flavor for, I think, bringing a snapshot for a consistency group, and that will help us more as a 6 storage group. Versus we start thinking about backing up the whole pod or having a snapshot being extended into a backup. Because for me, local snapshot remains what we are talking about, and remote snapshot is for us a backup.
Now, let me ask you guys, do you see a need for associating metadata with snapshots or not?
We do, and I think we have that in the proposal, where I view it as, labels.
But technically, if you are taking a snapshot and you want to restore from there, somewhere all the annotations and everything that you have built on top of a volume, which is like PV, you won't get them back if you're really talking about the backup.
Yeah, well, I'm thinking that the things that you might want to record, I mean, let's just assume the granularity of snapshots is volume, amount is volume. I might want to record what pod that was associated with at the time that this occurred. But would that
application was consuming it?
Yeah, well, the pod then might give you a clue as to what the application is. I don't know if we have on the table the idea that we'd actually try to snap orphan pods that aren't currently mounted to anything and have no volume claim on them. I don't know if that's I don't know whether that's contemplated as a supported use case or not.
Steve, I beg to differ here a little bit. The point, I believe, when a lot of legacy applications are moving to framework like Kubernetes and Mesos and Docker, like when I'm containerizing my application, the fundamental assumptions behind application is anyway changed. That application should be able to survive a crash and rebuild its state as long as the data remains valid from where it can originate its state from. So if we think about having a snapshot or a backup, keeping the information about who is consuming it, we may not be attacking the problem right. We should rather keep a data which is self-sufficient for an application to consume to revive its state. I think that should be the right problem statement. But I completely I do not really understand the part that why we want to keep the consumption part of a volume or data into the backup itself, because application can start anywhere else, and technically I can start some very different application to consume the data. I may have version 1 of the application which actually did the backup, and when this application died and all those things, and other applications start, technically that application should also be able to consume this data as long as they're even compatible. So bringing a consumption into the data which is backup may not be the right thing to do, but that's completely my opinion.
Well, I think you might be right that there's demand for recording the entire amount necessary to resurrect it, which to me, if it's containerized, the identity of the pod is just a starting point, but to your point, what you'd actually need is the images. I don't think that's properly within scope of the storage thing. That's a backup application could do it, but that's within that backup application, and we shouldn't architect that here in the storage thing. But I have no objection to the precursor of at least identifying the pod so that you'd have a chance of looking up the YAML and figuring out what those images were. And I'd make it an option saying that if you want to specify this metadata when you do the snap, fine, we'll let you put it there. It's optional though. If you don't want to say anything, fine, we'll still do the snapshot. But I think by enabling at least that option of taking, you need to capture it at the same point in time as there's a chance that if it goes and tries to look up this association, it's changed between the time that snap was taken and when it attempts to record it, and that results in big issues in my experience. So the ability to specify it right in the same API that makes the snap means that you've at least given people an opportunity to record some metadata, at that very instant in time, so that if it's subject to change, we got it at the same moment in time. Now, the downside of that is there any scope on the size of that metadata? I mean, if what ends up happening is it gets thrown in etcd and people end up throwing, a gigabyte of information in there, that's not going to be real Kubernetes friendly.
I still don't think we need to capture that though. So what would be the case where they'd be coming 10 minutes after creating the snapshot? If this is driven by the backup application.
Oh, there's plenty of it, like you have limited bandwidth to move it to secondary storage.
I mean, but you're not moving anything yet. At the point where backup application says, okay, I need a snapshot, would also be a point where they say, okay, pull out the metadata for me to keep. And then it doesn't matter when I go to that snapshot and actually move the data off of it. I've already got everything I need. I just need to actually go get the data then.
I think there is a use case of associating metadata with the snapshot, but whether it needs to happen at time of snapshot or it can happen when you initiate the snapshot operation, I actually agree that most of the use cases we've seen in Canister, you have the metadata you need at time of initiation, and we put it in labels, right? So labels is that key value mechanism that is pretty extendable. If you have data that is in gigabytes, just put it somewhere else and put a reference to it in the label. That's a mechanism. Don't put gigabytes of data in etcd.
I can see that works if you assume that the backup application triggers the snapshot, but there are some products that work with recurring snapshots, and then they do a lazy convert of those snapshots to backups, in which case that breaks down because the backup app is actually not in charge of making the snapshot.
I'd like to raise another issue, it's not related to metadata. So ignoring all the issues related to metadata, there's a more basic problem with backups, which is on the restore side. Everyone, there's a little joke about everyone's really good at doing backups, no one's really good at doing stores. Yeah. I think there's a tacit assumption that the difference between a backup and a snapshot is backups are some sort of external artifact you can move around. It's more independent of the storage system. But what that means in practice is that when you want to turn a backup back into a volume, you're not going to get exactly what you had before. Whereas I think there's an assumption with the snapshot that when you turn a snapshot back into a volume, it's going to be exactly what you had. And the backup might just be a tarball in the file system. And tar does not capture everything about the file system, so there's a little bit of data loss. I think it is kind of in scope for this group or maybe CSI to figure out how would you turn something that you call a backup back into a PV in a standardized way, and maybe you call that more like a volume import. But I think that's the issue that would be in scope for this group. All the metadata stuff, yeah, you can figure out in another venue.
I agree, and I think that's where restore volume, for example, where today we talked about restore volumes from a snapshot, but really being able to import a volume, or where you're restoring volume and your source is another PV, for example, is something we should.
So if you look at the CSI snapshot design, we just got merged. The restore volume source can have different types. So we have one for snapshots, but it could be
A volume.
It could be something else.
Or a tarball or something else, where then you can go and materialize a PV from there or a PVC.
Now the interesting thing would be so basically we have an import option for snapshot, and that can be extended to some other sort of like tarball or something else. An interesting thing would be, can we do export for something other than snapshot? Snapshot is, we have a create snapshot option. Do we have a ability to trigger a backup that results in a tarball? Where does that live? What does it generate? Can that be standardized? And I think based on what you guys have been saying so far, that's something above this thing's purview.
Yeah, I think if we enable somebody else to write it, we're fine. We don't have to.
I think this can provide some basic templates It's like, just to have, like, this is what we did in like Cinder, Manila, or have that, right? We have some basic APIs. You can back it up to another device. It could be an object store. Actually, there's a backdrop for Google Cloud as well. So,
But the question,
we have something.
but the question remains same. What do you want to back up? First, we have to solve that problem.
Yeah, so I think
You need to create a primitive, which is a way to export and import snapshots.
So
And then you can build backup on top of that. But unless you have that primitive, you don't have anything.
like backing up, like promoting a snapshot to a remote place, that kind of a thing. But then we need to define what the remote place would be.
I don't think we even need to go that far, right? We know how to get data into a PV, and as you start a pod, you write into it. So we can get external data in, and I think our responsibility should really stop at the point where we provide primitives that are sufficient to build a backup app.
Yeah,
Right? So supporting taking a snapshot and getting some minimal amount of metadata with it, right, should be sufficient for us to support the backup portion of that. The restore portion of that, I would argue, we could do today in an app. Now, perhaps we could make it a little bit smoother through the restore stuff, and so what we were talking about the swizzling of the PVC to PV mapping could make things smoother. But I think it's that level of primitive that we should be worried about in the SIG, not the sort of higher level do it all, right? Because there's a lot of different ways that you could do it. And I think various vendors will have their own ways of wanting to do that and creating value from adding those things.
Yeah, the only thing I add to that, not on your list, is maybe to entertain this concept that something running in a pod could trigger a backup of itself and be able to supply, maybe just inherently have default credentials saying that if your code in this pod, of course, you're vetted to be able to do that. Because they could totally corrupt themselves anyway if it's the code in the pod.
Do we have that already with the snapshot primitive? I mean, we could initiate a snapshot operation from the bot, from yourselves.
I'm not sure that that's even how you would really want to do the backup because of the cataloging issue, right? I think that you would probably want to trigger the backup application that would trigger the snapshot.
Yeah.
Right. So
Well, the
you
thing
get
is, the
proper
backup
metadata
application
capture.
would communicate with the app in the pod, which has the KS. And only that app knows when the KS has occurred. So at that point, it's the one that the external backup really can't assume that that thing has been KS. So I think that might actually be the way the workflow would run.
So for example, if you take something like Postgres as an application, you can configure it for continuous archiving. So you set there's an application setting, and it's going to continuously just keep taking snapshots or backups of itself. And that's what you would do here. And it could involve the snapshot API if you
Yeah.
wanted to.
Yeah, so the volume has the parameters, like so that one you can actually pass in, and then it can actually periodically do snapshots. Actually, Jim actually did a demo with the NAT controller.
Yeah, with the policy-based snapshot.
Yeah,
I could
actually that passed that in.
But yeah, anyway, if we put enough in there to enable that, the messy things would be that if it needs admin credentials, which you aren't going to want to have in there, if there was a way that just says if we can establish that you are this pod, then you can trigger a snapshot. That might be a nice to have.
Would that be admin though? It's a quick snapshot tenant operation, right? Or if you're talking about backup, but it should be a tenant operation for you to allow you to take snapshots. Right, so you own the volume and you own the snapshots. So does it have to be admin?
No, I think that the app running in the pod should be able to trigger snapshots. Now, maybe an admin would have a binary switch saying whether I want to allow this or not. But given that you allow it, then call it a credentialless ability to trigger one of these snaps.
Yeah, this is one of the use cases that did not work when we had the single API object, which was the non-namespace snapshot. Now with the two API model, it works well because you can create it's like a PVC, right? You can create a snapshot request, and you have access to that. And then the privilege or the data is non-namespace. So,
It sounds like the conclusion is backup, it doesn't really make sense in this state.
Well, enabling backup, but certainly not implementing it.
We expose the primitives that others can use to put backup.
build controllers like the one that Jane demoed.
Yeah, and even then, the backup itself, which might involve moving data to alternate storage, gets involved with data plane operations and things. I don't think we want to go there. At best, we want to enable an API that would suggest to a plugin that if you happen to have an ability within yourself to move, replicate, or copy somewhere else.
But that put an individual vendor take care, right? So
I think so.
in a
I
backup
don't
comes
think we need
in,
the storage thing.
a trigger can come from Kubernetes, but eventually a vendor plugin, a CSI plugin eventually can intercept that and trigger a backup to a remote place, just give the API response back to the controller who can take the backup and it's available to me. We end up creating a backup object in the system. Tomorrow we just want to create a PV, whether it says restore from a snapshot or restore from a remote backup, which is sitting somewhere. As long as we can form a PV out of it and vendor says, okay, the PV is formed, it should be directly consumed.
I don't know if migrate as a primitive like snapshot makes sense because that might you let the vendor implement the storage vendor implement the specifics behind moving the data, but you want to trigger it and you want
Trigger the migration?
if you're building a backup application or you're building a controller or something external that wants to.
I agree, but I think few of the customers that we have talked to, for them, anytime a backup is triggered, the implicit assumption is it is data sitting somewhere external. So it means migration is a very natural phase of a backup, unless you were talking about like migrating backup from one place to another.
Yeah, so I think that's the use case. So you're talking more about kind of the durability of the backup, which is moving
No, I'm talking about the
offsite.
same thing. Like if you have a local snapshot, you are promoting a snapshot to a remote place that eventually turns into a backup.
Right, but it's more about moving it off the tenant, right? Moving it to some location that doesn't blow up when your appliance blows up.
I'm saying like keeping that in under control.
Yeah, and then the other use case is when you want to move data between clusters, using and there's one piece of data which is the snapshot or the backup. You want to be able to trigger that if the storage provides that capability.
Maybe more places than just kind of local and remote, right? There might be a different region if you move between one.
That's fine. That's fine. But I'm saying like you don't need to classify something as a local or remote. This is just a region. A region can happen to terminate on the remote side versus the local side. Like you can keep things very abstracted out. Okay, backup sits with you. Sorry, snapshot sits with you. Backup sits somewhere away. So that could be
requires to know how to restore the line that's not just region.
multiple ways to solve the problem. You can always keep a local copy along with your remote. So if your local copy present, you want to restore, you always restore to your from your local copy as long as you have it. You don't have it, you go to the remote one. I think they'll always remain a vendor-specific solution, irrespective. Kubernetes can define a strategy to invoke some operation and how people see the catalog once they're fired in. I doubt that we'll be able to come to a common schematic where every vendor will fall into the process workflow part of it. But as far as I understand, migration of between two clusters we're talking about, yeah, that's where something you might want to attack these problems. But again, in that category, what do you want to migrate? Like just the PVs, the pods, the overall strategy? Because we have few customers who are using Kubernetes, and they ask, what do you recommend for having two clusters, Kubernetes clusters running in tandem for business continuity cases? And if you want to move my entire infrastructure from one Kubernetes cluster to other Kubernetes cluster, what do you do? And it's about like this is not something that a storage vendor would define. What should you do? Yeah, agree.
you maintain all the states on storage, but end of the day, there is more than what you maintain on storage. So I don't know whether there is a bigger initiative at Kubernetes level, at maybe SIG infra level or anywhere else.
There's SIG multi-cluster.
Okay.
Not sure whether they dealt with data migration issues at all. I think they're dealing currently with just being able to have a common registry for multiple clusters and things like that. I don't think it's on their radar.
Managing multiple clusters rather than moving things.
So I was wondering, sometime back I heard there was a project like Kubernetes or something, right? What was that?
Federation. The SIG multi-cluster originally started off as SIG Federation, and Kubernetes was a project of that. The idea there was you take the Kubernetes API and you promote it to an Uber API so that all your clusters are managed by this Uber Kubernetes API, which is identical to the Kubernetes API, but is smart enough to be able to route amongst multiple clusters. It was an interesting idea theoretically, but in application, it's difficult to actually do because it's always playing catch up with real API, and it's not quite as there's been a little bit of a pivot within that group. There's a set of folks that are still working on that project, but there is another part of that group that's focusing on the multi-cluster aspect of registry and just being able to manage clusters, multiple clusters in the same way.
That's all I have. Yeah, I think as a wrap up is, I think what's in scope is let's get Snapshot done. I don't know if we even had a consensus whether we believe metadata associated with one is needed or not. And you know, I don't even know here. I brought it up, and I'd say it's a nice to have, but not necessarily a requirement for B1.
We faced 4 years.
Yeah. And I think backup will declare it out of scope, other than to enable this through the API, but we're not declaring we own backup applications within the storage thing. That's, you could implement them in Kubernetes, but it's not something that we're going to start a work, a sub-project or working group underneath ours.
Okay, so we've got 2 more minutes. Any other thoughts on this topic?
So one thing. So what is the overall strategy with people who are managing their entire storage using Kubernetes? Like, idea is to give them a comprehensive way to interact through Kubernetes to perform their day-to-day operations for storage, like end-to-end, without going to the vendor-specific APIs.
So I think it was Luis who said yesterday, this SIG does not want to get into the business of managing storage.
We're not a storage vendor. Right?
Yeah.
We want to leave some meat on the bones for storage vendors to bring their value add.
No, that is agree. But if I'm a user,
yeah,
I'm purely thinking from a user's perspective. Right. If I'm a user and I place my bet that I'm going to use Kubernetes for my data center, whatever my test, dev, or user operations I'm going to provide. Yep. If there are 10 fundamental functions that I do every day, if I'm able to do that from a single place, yep, I would do that. Yep. Right? So I agree, like people can write a lot of wrappers and on top of it, which can write through whether going to Kubernetes or connected to vendors. But shouldn't that be our principle that as long as we can let the user do all fundamental operations related to his storage?
So what kind of fundamental?
So let's say getting the storage access, creating PVs and all those things, PVCs, snapshots, restore.
So our charter is more the subset of functions that's common across every cloud.
For consumption
storage. Yeah.
But
So
sorry, I wanted to understand your concrete use cases.
So I'm saying, let's say snapshot content. Yeah. Okay. Some point in time, snapshot will also bring in like snapshot schedules and all those things.
No.
Okay.
Because that's not a common snapshot feature.
No, but this is.
Do it.
Operators. You could build operators.
Yeah, you could build an operator.
I'm saying like more and more common storage vendors will fall into this umbrella. Like you will have an on-demand snapshot, you will have periodic snapshots, right? So I agree, we are doing on-demand snapshots right now, but eventually people have periodic snapshots. So now it's up to us whether we want to expose this as a Kubernetes functionality or we say the user, okay, hey, we don't provide it right now, go to your vendor, specify the policy over there, out of Kubernetes control plane, you keep doing those stuff. But then we'll not be able to consume those snapshots because we never fire them. But for a user, there are two sets of snapshots now, one he triggered from Kubernetes, and one he or she triggered something from the vendor.
I think in that case, the primitives that we provide allow you to build a controller on top that would allow you to do periodic snapshots. And so Kubernetes itself natively doesn't need to understand the concept of periodic snapshots, but that functionality, once we have the basic ability to do snapshots within the Kubernetes API, is possible through the Kubernetes API.
All the building blocks are there.
So I think let me phrase the question a little bit. So in the same context, if I have a foreign entity which produces exactly the same object that a Kubernetes operation does,
okay,
I can bring that foreign entity into the Kubernetes umbrella, like what Cinder does, right? Where is John? Maybe John is not here, but I think Cinder has something as a managed volume versus
Manage existing.
I'm sorry?
Manage existing volume.
I think so. There is something like you can export the external volumes into the Cinder umbrella, and Cinder starts managing them.
Yep.
So that brings a very good value for a user that as my user consistent.
You can do that with Kubernetes, right? With pre-provisioned volumes, as long as you create a PV object for any of the existing volumes.
I'm just taking that as an example.
Okay.
So if more and more cases come like this, as long as we have a way, whether through an operator or a controller or my custom stuff, like shouldn't that be the direction we are in? Or is it something that is still left to the people? Like if you want to implement a certain functionality, it's up to the vendor that how do they provide it to the user.
So you're people distributing Kubernetes, and they may want to distribute a different service catalog of features that has these particular functions. We wouldn't want to do that as part of the core framework.
So is your question basically like this higher level functionality that could be built on top of these primitives? Should it be the scope of the SIG?
So let's say we build a data protection mechanism. Right now, I'm not sure like in our SIG storage, we have any data protection mechanism other than snapshots?
Just a snapshot.
Like somebody want to define what kind of volume they want, what kind of protection schematic they want. Somebody just want to use recording, replicas. Like I see a lot of vendors do that today. Basically, they ask for an optional parameter like how many replicas do you want, what kind of volume do you want. Some point in time when they grow as more common field, do we want to attack them ever? Do we want to address them ever? Or do we still want to go with the common volume?
Are you trying to say like, because I think you guys are trying to say like, we want to provide building blocks or we need to do these bigger operations. But I think what you're saying is like, what if these other operations become sort of like building blocks in their own right?
I'm saying whatever the fundamental operations we are building, we need to leave enough hooks for further functionality to get plugged in ever. Even if Kubernetes attack them as a common block or not, at least vendor have a way to push the things into them.
I think you were pointing to the features versus operator paradigm that we were discussing about that. So we have a set of features and anything that we want to extend as an operator, or maybe if there's enough value with operator to report back as a common feature. And as long as we provide the right set of capabilities and the right set of hooks so that operators could be built in a very easy way, I think that should be the challenge. So isn't that storage classes what you're talking about?
No, storage class is one way of doing things, of course.
I mean, people are using that today. I see that you create different storage classes, specify different SLAs you want in there, and then that's what we do.
That is fine. I'm only talking about like operational semantics. I'm not talking about how the PVs and all those things look like. I'm talking about like the way we trigger some of the operations and the workflows that are visible to the users. For like primary example, what I took for a snapshot, like bringing a foreign volume into your system or doing something similar. But I think it's a fair point. So
VMware actuators some of this, right? Their volume plugin. The storage class, you can actually specify your VMware ERS policies. I mean, it's like almost a full language that they can express in storage class.
We do something very similar.
They do that on the back end.
That's fine.
You're not asking for any particular feature. You're just asking what's the scope of the SIG, right?
Yeah. I mean, at a very high level, the point of Kubernetes is to abstract away storage implementation so that the consumers of storage don't have to worry about the storage that they're consuming. If there is common set of functionality that makes sense across a bunch of different vendors, we can consider pulling it into storage safe. What we don't want to do is when there are 20 different ways of doing something, become very opinionated and start pushing a specific way. That doesn't make sense for Kubernetes. Kubernetes wants to be very extensible, very customizable.
Portability is one of the key tenets, right? Is you want to be able your application to run here or here or here, not go right back in storage or platform.
Yeah, and we want to keep the kernel very small, unopinionated, and extensible. And folks should be able to add things on top of that. If things naturally evolve that are building on top of it, which are storage related and they're broad enough that they're useful to a large number of people and multiple vendors, absolutely, SIG storage could be a home for them. It wouldn't necessarily be in the core Kubernetes repos, but it could be like in the SIG storage repo. But yeah, I think that's the general target. Cool. Any other comments on that? All right, cool, great discussion. I think that's pretty much it. That was the last discussion of the day. There's a bunch of other items that we didn't get to, but this is typical for a face-to-face. We always have way more to talk about than we have time. We'll probably do another one probably 2 quarters or near the end of the year or early next year, depending on how things go. Thank you very much for your time. It's absolutely wonderful to see all of you here. I think it's Steve Watt or you who likes to say the brain trust in this room is ridiculous. Like I look around, I see folks from like NetApp and all these amazing companies. So it's really, really awesome to see all of you here, and thank you for coming. So we'll have the regular bi-weekly meetings starting next week, and hope to see you all there. Thank you very much.
Thanks to Steve VMware for.
Yeah, thank you for sponsoring.
Maybe next time, well, if we do it by end of year, we've done it before at KubeCon, so that might, if we can get a venue, maybe that would work out. But otherwise, I hope next time if we host here, I can get it on campus.
This one ruined me.
Well, it's unconventional, and I think it worked.
Yeah, I like the couches.
And Karen, thank you for taking notes. And so last item of the day is any feedback, anything that we could do to improve this next time and make it more effective?
Maybe agenda we can work
on ahead of time?
Yeah.
So
the
we've
thing
tried.
is, people put it on and then they don't show up. And you
Yeah.
hate to discuss something where, I think we even had a couple on there where nobody materialized to represent the topic.
Bottom list right there.
Put an agenda where people need to put a proposal along with.
Yeah,
Just
and it's
cover
not just that,
line
it's
item.
the voting for it.
Yeah.
Like having people vote ahead of time doesn't really work. So it's kind of nice to just do it in the beginning and say, what are we going to work on?
Yeah, I don't think it's fair to have voters who then subsequently don't show up either, right? So I think that it takes time to vote, but I actually like the vote because it kind of scopes
That's
a
like
consensus of
Yeah.
what people think is important.
And it doesn't take that long. It's about half an hour. So considering we've got a 2-day session.
It doesn't matter anyway, because we reorged them after the voting.
Yeah, people don't show we can vote their items down.
This is Russia voting.
You just
Yeah.
Just topic in
Part of it is if you don't get your thing on there, there's always talk it up over lunch or dinner or something like that. So if there happens to be anybody else, I'm headed to the airport as soon as I pack up. If anybody else wants to share a ride to San Jose Airport, let me know.
All right, cool. Thank you very much.
Thanks,
That's it.
Todd, for seeing.